and mathematics. So you're all welcome to this session that we are to start now. We have around 9 presentations that will be given in this room between now and 1 o'clock. And I wish to confirm the presence of the presenters. So kindly let me know if you are there. We have the first presentation from Kitaka, Ke, Maina, and Ngo. Is the presenter there? Kitaka. Kitaka, Ke, or Maina, or Ngo, whoever is going to make the presentation amongst the three authors.
Kitaka.
Kitaka. Oh, you are doing it online?
Yes.
Ah, great. Okay, then we have Mosiori. Is he there? Mosiori. Then we have Ekwar EP, Muya WA, and Zula K. I think I saw Ekwar around. Ekwar, Mr. Ekwar should be there. Then we have Malali, J, Oye, and Asio. Is any one of them there? Malali, Oye, or Asio? Is any one of them there? Kindly confirm your presence, please. Then we have Kibiwot is there. You're most welcome, sir. Thank you. Then we have Eric Odhiambo, I think, Ongondo, and Otachi. Is Eric there? Eric, you're presenting online. Are you there already with us? Eric? Eric, kindly confirm that you're there. Then we have Tembo. I can see Tembo is online. Tembo, Kihia, Kitaka, Obren, Hansen, Mbaru, and Karaoke. Tembo is the one presenting. Kindly confirm that you are online already. Mr. Tembo?
I'm present, Dr.
Okay, thank you. Thank you so much. We'll call you once we reach you. Then we have another one is by Liaka, Gwena, and Milewa. Is any one of them there? Liaka, Gwena, and Milewa. Even online. If you are online, kindly let us know. Liaka, Gwena, and Milewa. Then we have Imbusi, Wakoli, Sikuku. Huh? This one. Okay, fine. Okay, those are the people that will be presenting with us here. Eric will be doing it online. And our first presenter is going to be online. You'll present online. That is Kitaka.
Yes, please.
Okay, thank you. I would request that Kitaka shares his screen so that we may see his slides. And I want to request that we start this session. My name is Steve Odur. I'm the Dean Faculty of Science and the chair of this panel. The rapporteur for this session will be Dr. Mercy Homalwa, who is with us here. Dr. just rise up and let them know that you are their rapporteur. Thank you so much. We'll be given 10 minutes for presentation, followed by about 5 minutes of questions and comments after each of the presentations. And we wish that at least we try to be in time. We try to make our presentation within that time that is allocated to you. So I don't know whether Kitaka is starting to share his presentation. Okay, we are ready to go, and I want to welcome Mr. Kitaka, Ke, Maina, MC, and Ngo L, who is going to give us a presentation on research work which they did under the title of Investigation of Voltage Stability of Power Distribution Network in Nairobi region. So, Mr. Kithaka, you are welcome. You have 10 minutes to give us your work and findings. Thank you. Welcome.
Good morning, participants. My name is Edward Kariuki Kithaka. With my co-author Stephen Maina, Professor Christopher Maina, and Livingston Gore. I'm presenting an investigation of voltage stability of power distribution network in Nairobi region, and my content of this, what I will discuss in my presentation is the background.
Excuse me,
the problem.
Mr. Kithaka, kindly go to the slideshow. Make it slideshow, please.
I've done that.
Not yet. We are not seeing a slideshow. Down there, near the corner. Okay, just around there. You're almost there. Not that one. Come to the no. Come to your left. 2 steps more. 2 steps to where you are. To the left.
This one?
No, you go to the corner. The slideshow is somewhere around there, the lower side. After the 60%, that should be the slideshow. Down.
Why is that? I think.
I'm sorry, I may not be able to help because you have the cursor yourself. Just the computer icons down. Yeah, we're almost there. No?
This one?
The one that looks like a glass. Down. Near where there is a percentage given. 60%, then the next one. The other side. Come this way.
This one?
No,
this one?
No, yes. Click it. Yeah, thank you.
Okay. Good morning again, once more. My name is Edward Kariuki Kithaka. I'm presenting an investigation of voltage stability of power distribution network in Nairobi region. My co-authors is Professor Christopher Maina and Professor Livingston Gore. On my presentation, I will cover research, problem statement, aims and objectives, methodology, results, then the conclusion. Then I'll give the progress of what I'm intending to do in future. On my background research, due to the increase in domestic and commercial buildings in Nairobi region, there has been increase in requirement of electricity to connect to those new developments. This therefore has led to fluctuation in road in Nairobi area, and it has demanded that we increase the number of infrastructures to cater for the buildings that are coming up and even the large-scale industries that are in Nairobi. This has been a challenge as per the report of Kenya Power Provident, in 2021. Therefore, my research has been to check how to keep the voltage stability in check so that blackouts can be reduced. Again, there should be no downtime in the large-scale new industries that have been developed in Nairobi. There has been always a road demand as per the report given by Kenya Power. That is annual, there is a 40% need of load every year, 4.5% increase in demand yearly, and on the peak, there is usually the demand of power that is usually 2,036 megawatts every year. To my problem statement, with the increase in load, we need to expand the access of electricity, voltage instability, and solve the voltage instability challenges. These are some of the, these are in the, and solve this challenge of load problem. In my objectives, I will cover in my objectives, we decided to develop, to evaluate the voltage stability of infrastructure in the Nairobi area. And by this, I want to develop a model to perform the road flow solutions in the power distribution system in Nairobi area using a PSAT MATLAB environment. This is a roadmap towards my research. I performed the road flow analysis and identified the overburdened weak buses. Then I did the analysis, PQ analysis. I did the analysis, performing the sensitivity and utilizing model analysis form. I did the road flow analysis for the, I designed and I developed the model, then I did the road flow analysis for Nairobi region. The methodology I used PSAT. I used the PSAT and MATLAB model software for the modeling of the system in Nairobi. Step 1, you have to come up with the lines that are around Nairobi, the electricity line that is a 220 kV. We have 132 kV distribution and 66 line. The PQ buses will cover the Masinga, Kitaru, Kamburu, and the different engine generators of the Nairobi. Then I obtain the operating buses and the angle profiles, active and reactive flows and system losses. I will determine the eigenvalues and the eigenfactors with the power flow Jacobian matrix. I will identify the buses, use buses prone to voltage variance due to high roads by analyzing the participation rates. Then I will analyze the incremental relationship between the reactive voltage and reactive voltage through a range of operating conditions to access the system for voltage stability. Then later, as a solution to as a way to try to find a solution to that instability, I'll repeat the process now with the fact devices in the weak bus to get a solution. Equation in the methodology, I will inject, having injected power in the H bus, from the generation, then to the load, you get the difference of the power injected and the power used in the load. Then I'll get the reactive path in that H bar that is under test, from the generation, then to the load. Then in the next equation, I'll be able to get the eigenvalues of that bar that is under investigation. I'll be able to get the investigation, the participation factor. Using the participation factor, I'll be able to get the weak bars that needs corrections so that to reduce that voltage instability. This is a model that has been developed for Nairobi region, containing different buses to investigate the road need in Nairobi and what causes those blackouts, like the recent ones that has always been that was in JKI. And some of those problems will be able to be solved with the proper test of this model. Having done the modeling, having analyzed this model, I came up with the real power profile, the first graph, and I was able to get the magnitude of voltage in Nairobi grid. We further did analysis for lead power injections and the reactive power injections on the grid. As you can see, the highest bus on this side, on the positive side, it is the bus 61 for Orakati that end the highest positive power injections on the grid, or the one at the bus 23 that is on the negative side of the graph. It is the Juja Road bus that end negative injections of approximately 4 per unit. We have also the second largest in the positive side, this one. This is the industrial area bus that end a lead power injection. Then I have the reactive power injection using the PSAT, the PSAT toolbox. Then the eigenvalues are exported to Excel.
Sorry, Mr. Kitaka, I request that you try to hurry up, wind up, because your time is already elapsed. Just give us a summary of the key findings, please.
Okay. I was able to find the weak buses that need improvement in my line, in Nairobi area. And in my conclusion, having model
Are you there? We are not getting you.
You can hear me?
Yes, yes. Go ahead, please.
On my model, I conclude that having the model, the distribution area of this Nairobi area, I'm able to find the weak buses that need improvement. I think this thing is hanging. I'm able to find the weak buses that need attendance so that to reduce the voltage problems in near future. Thank you.
Thank you, Mr. Kiteka. Let's give him a round of clap. Thank you for the information. At least you've informed us of the challenges of the Nairobi power supply. I have one question for you. Where is the key problem? Is it that the power supply for Nairobi is not adequate, or the infrastructure is the one that is causing challenges, resulting into the fluctuations in power supply?
It is the problem is due to increase in those residential houses and the new industries. The infrastructures are not enough. Therefore, you find that the Kenya Power has not been able to equip the infrastructures for the new development in time.
Thank you very much. Anybody with a question from the floor? We'll only take 2 questions because of time.
Yeah, thank you so much, Chair, and thanks so much, Kitaka. The question is, did you really solve the problem, or you just identified the problem?
I identified the problems, and because the research is still in the process, I'll get the problems which I'll publish in form of a journal paper later in my research.
Thank you. Next question, please.
Thank you, Edward. I have one question for your model.
Yes.
Could you kindly just summarize how the model works?
The model, is actually a distribution system for Nairobi region. It has a total of 63 buses, 43 transmission lines, 43 PQ buses, 7 PV buses, 23 transformers, and generators, and 32 loads. In that, that is what I've covered in my model.
Thank you, Mr. Kitaka, and thank you so much for your presentation. Let's just give him one more clap as we prepare to invite Mr. Ekwar.
Thank you.
Okay, our next presentation will come from Mr. Ekwar EP, a paper by Mr. Ekwar EP, Muya WA, and Zula K. And the topic is water quality assessment of tap and kiosk water supply systems in Lodwar town in Turkana County, Kenya. Welcome, Bwana Ekwar. You have 10 minutes for your presentation.
Good afternoon. I'm Paul Ekwar, and I'm going to present on the water quality assessment of taps, that is piped water, and kiosk water supply systems in Lodwar, in Turkana County. This is part of my thesis, of my master's thesis, that we co-authored with Dr. Muya and Professor Kitaka. So, as you may know, we have a global challenge of water access, and a joint monitoring report by UNICEF and WHO for the year 2022 reported that 2.2 billion people lacked access to safe or clean water. And you'll find in many urban areas there is that access to water, and especially the informal water settlement or peri-urban settlements, areas which have intermittent water supply systems or may have piped water system but don't have water. And so that Lodwar is part of that growing urban town, especially after the inception of devolution. The town grew very fast, and therefore the demand for water was high compared to the present water supply system in town. And what the water utility did is to establish some water kiosks in informal settlements in town and the areas that are outside the piped water system, including an IDP camp. So, but the concern of in that water supply system is the quality of water, because the data that we get from the hospital around Lodwar is that there is a high rate of waterborne diseases that has been reported in the town, but also the fact that normally during floods, when it rains, the water infrastructure is destroyed, and you find that the water supply, which is mainly boreholes, is affected. So this study, we sought to try to see whether the data that is reported in the hospital correlates with what the quality of water that the residents of Lodwar town are drinking. So I'm going to skip that because all of us knows that Lodwar town is in an arid area of Turkana County, which means the water supply, the availability of water is an issue. So that diagram is shows the two water systems. The first one is a kiosk water system where you get water from the bowl, then to the distribution tank, then it is piped to a kiosk where the consumers get from and therefore take home. Then the second supply system is that is now the piped water supply system. It uses two bowls which feed one distribution tank, which now then goes to the taps and to the consumers. And below there, the table on your right shows the number of samples that we took across the supply chain. And from all that supply chain, we took samples from the bowl, the distribution tank, and the taps and the consumers. So you can see the kiosk has 4 points, and the piped water system has 5 points. So in terms of methodology, before we went to the field, all the equipment that we required for analysis or for data collection were pre-washed with acid water, but also getting especially for the biological, because we were analyzing E. coli, the fecal coliform, doing that, all that, disinfection. So during field work, we used universal meters to measure the in-situ parameters in the field, including temperature, EC, turbidity. Then what we did is that after we collected the samples, we put them in cool boxes for at least for the day. Then later we took it to Turkana University, because we were using Turkana University lab, where we refrigerated some of the samples because we could not analyze all those samples in Lodwar. So we brought them here at the LWM lab, water quality lab. So, but the fecal coliforms we did in Turkana University lab, using a water kit. We call it the Laukwa water kit that has been developed by Oxfam. So that is to bridge the gap of the time frame that it is required for the analysis of fecal coliforms. And so in the lab, we use standard methods that listed in APA 205, but for the bacterial call, we used the Delacroix water kit because it is list how you do, and we used in the water testing kit. There is also a pool tester that you use to test FRC, free residual chlorine. So after that, I used Excel and SPSS to analyze the data. And of course, mostly we used ANOVA because we treated all the sampling points as independent so that we know the relationship across the supply chain. So in terms of results, we did measure more than 10 parameters, but for the sake of this presentation, I selected 9. And those are results for the piped water supply. So the ones that I've indicated in red are those that are significant across the supply chain. That is temperature, DO, pH, and fecal coliforms. That is for piped water supply, what we call TAPS. And then for the water kiosks, we had temperature, DO, pH, and nitrates being significantly different across the supply chain. But we look at all those two systems compared to WHO standards for drinking water quality. It is only turbidity at the consumer, that is across the kiosk supply chain, that was above the recommended standards of 5 NTU. That is where you can see I've indicated in red. And fecal coliforms, which were found across all the sampling point across the supply chain. Yet the WHO standards indicates that fecal coliform should be 0 coliform forming units per 100 ml. So to summarize that is that, of course, that's what I've said. Temperature, DO, and pH were significantly different across all the supply chain. Then fecal coliform was significantly different across the kiosk piped water supply chain. Then nitrates were significantly different across kiosk supply chain. But also, you note that fecal coliform were detected in all the sampling points, which recorded high value above the 0 standard for that has been indicated by WHO. That indicates that the water were contaminated by fecal coliforms. So when you look at temperature, there are various factors which are also been reported by other researchers that like the time of sampling, ambient temperatures of the area, and in Lodwar, the average temperatures is around 30 degrees Celsius. Then the nature of storage tanks. Like the water utility uses for the kiosk supply chain is they are using these black plastic tanks, and then for the piped water system, they're using concrete tanks. So that also affects some, consumption, the absorption of sun rays, which increases temperature. And that high temperature increases microbial growth or biofilm formation in storage facilities. So that can be used to explain why temperatures were increasing, or all those parameters were increasing as you move towards the consumer. Same to DO. Underground water, it is low in dissolved oxygen, and therefore as the water is being piped across the supply chain, you realize that it is aerated. And it is aerated across the supply chain, and therefore the DO increases across the supply chain. But also for the kiosk supply chain, you realize that during the field work, we found out that those tanks were not leaded, and therefore you will find that birds will also come and take water from the tanks, especially when it overflows, and you'll find that because it is not, it is just isolated, the birds also take that advantage of making part of those systems their homes. So that also will have contributed to the increase of nitrates across the supply chain, which of course, as much as it varied across the supply chain, but was below what WHO recommended for drinking water supply. So I've talked about fecal coliforms. That could be as a result of handling of water across the supply chain, both by the water utility or the consumers during storage. And you realize that across all those supply chains, there is no water treatment that happens. So the water is supplied directly from the bowl to consumers. But when we talk to the water utility, they indicated that they do treat water 2 times a week. But according to the results that we got, measuring the FRC across the supply chain, we only detected that once in 5 weeks at the taps only, not even at the distribution tank where they claimed to have done the water treatment. So in conclusion, we can say that inadequate water treatment or poor hygiene, improper water handling, both at the source and at the consumers or across the supply chain, and lack of water quality monitoring could have influenced water quality in Luda town. But also fecal coliforms that were recorded across all supply chains is an indication that that water is contaminated with fecal matter, and therefore, according to WHO standards, it is unfit for drinking, not unless treatment is done both by the water utility or at the household level. So, and that is can be seen or observed when you do FRC test, which I've said was detected once in the piped water system across the supply chain. So, in terms of recommendation, which we of course talked with the water utility because the water surfaces is a default function. There is need for treatment both at the source before the water is supplied to the consumers. Then the water utility, of course, in collaboration with the public health department, should do regular water monitoring. Of course, depending on the availability of funds to regularly so that they can ascertain the quality of water that they supply to the communities. But also there is high need for community sensitization in town so that they are able, even if the water utility is not able to treat that water, they are able to use other homegrown or those other ways they can use to clean that water, like use of aqua tubs, water guards, or even boiling or filtration, so that they can improve the quality of water that they consume. So thank you so much. I would like to, of course, acknowledge the Rotary Club of Vienna, because they're the ones who funded the project. Then, of course, the guys who helped me out in the field and in the lab, but also the Oxfam GB office in Turkana, who are able to help us with the water testing kit through Engineer Owino, but also individual water vendors at the kiosks, the consumers who allowed us to do the water testing, and of course the county government of Turkana, because they're the ones who are in charge of supplying water through the water utility. Of course, and Wetlands International, where I work, they're the ones who facilitated me to this conference from all the way from Turkana. So thank you so much.
Thank you, Mr. Kwar, for the very nice presentation on the status of the water quality of Turkana town. My question is, have you shared this with the county officials, especially those concerned with the public health?
Yes.
And how receptive are they? What mitigating steps are they taking?
Yeah, I have talked with the public health department, but also with the water utility, Loasco, about the same, because the results are not published. That was an informal meeting But we were planning after the result is published, we are going to call the stakeholders through what they call a West Code that brings all WASH partners together so that we can present the result. But I think 2 weeks ago, we talked with the CEC for water services, and they are in the process of acquiring chlorine dosers that will be installed at each bores in town.
I think that would be a very good step so that your findings contributes to good health of the community in Turkana. Any question or comment? Yeah.
Okay, from the study, we realized that you are dealing with a supply chain from the kiosks and the tap water. And then from the results, if I'm not wrong, I think the kiosk supply chain was better in quality compared to the tap water. So what would you recommend? Because I expected a recommendation on that line as far as the consumers are concerned. Secondly, under the acknowledgement, I expected your co-authors, who were your supervisors, to also appear there. I don't see them. Thank you.
Thank you. Another question? Yes.
Thank you. My name is Imali Dixon Odwari, CEO Aquatech. It's an organization monitoring water quality and quantity in West Africa and also here in Kenya. Now, do you have any point of collaboration where, as far as innovation and technology is concerned, to monitor the quality and the quantity of water? Thank you.
Thank you. We'll take only 2 questions, but please you'll be given the pink papers where you can put down your questions and you'll respond to them, please. So, Mr. Kwar, you're welcome to respond to the questions raised.
Thank you. Thank you, Dr. For about the kiosk water being of better water quality than the piped water system. I can say both systems are not good in water quality, because if you look at all those parameters, E. coli was the fecal coliforms were detected in all supply chain across all the supply chain. But of course, I can say, according to the result that I saw in the field, the supply the piped water supply system is better than the kiosks, but also because of how the water utility works in terms of monitoring all those systems. Because the kiosk supply system is intermittent. It is not intermittent in the fact that the water supply is not constant. Like there are breakages across the supply chain. Then about supervisors, I didn't acknowledge them because I believe we are co-authors and this is part of our work. So it is our work. So why should I acknowledge them? Then of course, our brother there was looking for collaboration. Of course, there are other programs that the county government is collaborating with other partners like UNICEF, the Water Millennium Alliance, and other WASH partners in Turkana County to monitor the quality of water. But of course, we have an issue of capacity, both in terms of infrastructure, the lab, and personnel. But now the county established a lab which will be launched during the World Water Day, 22nd this month. So, and we are happy also to collaborate with you guys if there is where you can contribute to that improvement of water quality in Turkana. And not only in Loda, but in all Turkana. We have a problem of water quality in Turkana because most our water sources is underground, and most of them are saline. So even these ones that we use in Turkana is along River Takwel. And you can see like the distance between one ball to another they are concentrated within a certain area. So we welcome collaborations in the future.
Chair, I have one comment. Just a
Yes.
comment, a very
Okay.
short one. Equad, that's good work, but I think your focus was on drinking water quality or just domestic water quality. That's one concern. Two, if it was drinking water quality, you know, of course we have this mineral water. We call it mineral water. But the reason why we call it mineral water is because there are some minerals, there are some cations, anions, you know, which are usually measured or analyzed in drinking water. Yeah, what I'm trying to say, maybe in future you can think of expanding the scope of the water quality, yeah, so that you avoid, for example, things like dissolved oxygen, which we do not need dissolved oxygen, yeah, as people, yeah, but the other aquatic organisms, of course, they need that. So that's my comment.
Thank you. I did that. We analyzed 18 parameters. It is only that for the sake of this presentation, I had to select 9. But we did even heavy metals, iron and lead, which of course were below detectable levels. Then the other parameters, alkalinity, all that, total alkalinity. But also chloride, fluoride, yeah.
Thank you, Mr. Kwar. May I know whether we have any question from our online participants also? Any question from online participants? Any question from online participants? Yeah, of course, there was a comment, of course, given to you about acknowledging your supervisors. I think it's critical because this was an activity concerning a student being supervised by your respective supervisors who contributed majorly to, of course, you coming up with the work that you come up with. So it's always in order that they are acknowledged. Otherwise, I want to say that we thank him again and clap for him as he goes to sit down. Well done. Now, the next presentation is supposed to come from Mwalali, Oye, and Asio. Mwalali, Oye, Asio. I hope at least one of them is in. Yes, they're in. Thank you so much. And this is a paper which is titled Effects of Antenna Orientation on Line of Sight Radio Channel for Microwave Links, a case of Busia County, Kenya, and a case of Oromia region, Ethiopia. So welcome. I think we already have it here, is it? We already have it here. Unless you changed it. Okay.
Yes. Ladies and gentlemen, I don't know, good afternoon. My name is Jackson Mwalali. I'm presenting a conference paper. I'm doing my master's at Muranga University. My co-authors is Dr. Oyel and Dr. Asio. As you can see the topic there,
sort it out.
It's okay. Good. Now, as you can see, the title there, characteristics of antenna polarization on microwave radio channels, a case of Kakamega County, Kenya, and Oromia region, Ethiopia. This is a research which I've done for some time. The idea of this research is to check the signal variations on polarization of antennas. You realize that most of the radio links we have, they are either using vertical polarization or horizontal polarization, and if they use both, you will find, we have found from the research that they use both polarization to increase capacity. Now the research we have done here is to use both polarization to increase the reliability of the system, such that during any time of the year, the system can be able to give almost 99.99% channel variability. You might have realized that during rainy seasons, you may be talking, especially these places where we have a lot of rain, you may find the link is cut, is because of some of these, when the RSL or received signal levels goes down beyond a predetermined level, the link cuts, and then we lose the connection. Now the research we are doing is now to come up with a radio link which will be versatile in all the conditions, whether rain condition, whether clear sky, it will be able to adapt whichever, and we will not have those communication cut out. A brief introduction of this, as you can see there, telecommunication, as everyone can realize, it changes very, very rapidly. Recently we were using 2G, now we are headed to 6G, which is under test. So we need to come up with a system which will actually be very stable and reliable, such that high-speed data, when it's being transferred, there are no cutouts. When we are transferring funds through across these links, it's stable. So this is the idea of this system, which will be more stable than the current systems. This is still the introduction. You can see there, the last there, RS measurement we are taking for pairs of site under no rain condition, clear sky, and under rain condition for different antenna polarization. Here in Kenya, I've done research 4 sites in Kakamega County, Kisumu County, Mombasa, and the northeastern Wajir. Then after that, I've done also four microwave links in Ethiopia, a place we call Sheshamene, Ngwela, and other places there, the sites are 4. But here I've just presented 2 for the purpose of presentation. The scope of work. Carrying out RSL measurement on different radio links above 10 gigahertz. You realize when microwave links frequency increases, it is affected by rain as frequency goes up. So here we are looking for those microwave links, especially radio access networks. You realize even this mobile we are using, you may find maybe here in Egerton. There is a booster there. All the people talking here is linked maybe to the next booster, which people call it booster. We normally technically is BTS, base transceiver station. So the link between here and maybe the next point, if it's Telecom Kenya or even Safaricom, you may find they're either using a fiber or microwave links. But most of the time they prefer microwave links because it's easy to deploy. Unlike fiber where it's stretchy, you get leads from all that. So Once the scope of work involves now, we take measurement on VP. VP stands for vertical polarization. We take data on that. We also took data on HP, that is horizontal polarization. And then now we tabulate the results for different microwave links. Then we represented the measurement data in MATLAB, and we analyze the results related to work. This is just like a literature review. You realize we have so many models which are used to model these micro links, but in our case, we just settled on the Freeze equation or law, which actually we base on free space laws. When the signal propagates through space, it undergoes attenuation because of maybe the atmospheric effects like rainfall, dust, and all that. But in our research, we capitalized on rainfall, which is the major issue here. Because the region we have taken, like the Mumias, Kakamega County, you'll find during the month of April, the rains are so heavy, and then I've worked there some time, and you'll realize we have issues of links cut due to those fluctuations of rain. This is still continues that. Now, this graph, you look at it here, is comparison of vertical polarization. When we propagate the electromagnetic signal through vertical polarization of the link and through horizontal polarization. You can see the green graph shows the horizontal polarization, meaning when the rain rate increases, the attenuation on horizontal polarization is more than the vertical. The vertical is the one on blue. And that is where now we are basing this system which we are coming up with. Now, here is the research gap. As I said, the existing microwave links currently in both in service providers, Safaricom, Telecom, and Airtel, they are using space diversity to curb this, especially northeastern Kakamega County and also Mombasa, to counteract those fading. Much fading, they use space diversity. Space diversity is where they use more than one antenna, and also frequency diversity, such that when one frequency is affected, the other one is not. But in our research, now we are using polarization diversity, where the system will have both the vertical and horizontal on the same system, such that, as you have seen in the graph, if horizontal is affected, the system will immediately change to horizontal, and then the system will not be able to lose the connections as we have currently. This is just how the setup of the system we were using in the field to collect data. We could have the OU means outdoor unit, that is the radio part, which we mount on the tower, and then IU is indoor unit, which we mount inside the room, or wherever, if it's out cabinet. Now, here are some of the tools we were using. Spectrum analyzer. That one we were using so that when we are on those different sites, because a microwave link, we have two sites A and B, then once we are on one side, we use the spectrum analyzer to select the frequency which we have transmitted from the far side, such that we are sure we are working on the right frequency which is being transmitted from the far side. Signal generator, we were using it in case the system itself, because we were using the system signal, in case it has an issue, we could generate the same signal, the same frequency, and then we are able to receive it at the far end. The microwave system we were using was above 10 gigahertz. The other thing is laptop and multimeter. Now, results. This table of results, I think I can be assisted. I had attached because it could not fit on the slide. I had attached it separately. I'm not saying, not this one. There was a table of results, which was big to show the results which we plotted in the, no, but it's, I had attached, but it's in my laptop. I don't know, but I know it will be an issue, but it's very important to show it. Okay. Now, the table we are looking for is where we plotted the two sites which we chose for the data analysis. That is the Mumias. We had two sites, Mumia and Kakamega. And then the other site is, we had Gwela site and Shesemene. So that table is brought here. You will see how we collected the data. And now from that table is where we have used now MATLAB to plot this. So I don't know. So we just proceed with that. Okay, that table is containing the data which now we use to plot this. So here are the two sites which we picked for the purpose of resource analysis. The first one you can see here is Bendanyao, Ngwela. This is a site in Ethiopia. And then the other one is Mumias Matawa, which is a site in Kakamega. Now, when you look at the results here, if you check the chart there, you can see CS. CS stands for clear sky. Look at the solid red line graph. You can see the signal is very high. You realize this is the RSL received signal. When you look at the clear sky compared to vertical polarization, which is dotted, you can see the signals are better when the microwave link is transmitting on horizontal polarization during clear sky. But look at the dotted one, that is CSV, you can see is lower than the horizontal on a clear sky. That is the comparison which is being depicted here. Now, look at during the rain condition, you can see the solid one, that is RC vertical. It has a very high level. Signal is received higher than RC horizontal, which is the lower one. So now from this is what I said. This system you can see during the clear sky, horizontal polarization is far much better as a better signal than the vertical polarization. But come rain time, the horizontal now dips down. Look at it, it was at around 36, minus 36 dBm. But during now the rainy season, it sank to almost 48, which if you take that 6 and the 48, that's almost 13 dB down the line. And if you use the 3 dB point, if we say, for example, this we were transmitting 2 watts, when the power goes down by 3 dB, the power in watts halves. So you can see if it was 2 watts, drop of 3 dB, it goes to half a watt, to 1 watt. Then a drop of another dB, a quarter of a watt. So you can see this drop is almost 13 dB, so that power in watts has gone so low. So this is the idea behind this system, which will use both polarization such that it will be able to counteract any variation in weather. Now, conclusion. A comparison of RSL achieved by a vertical polarized antenna system and the horizontal polarization antenna system on our measurement data showed that during rain condition, actually this is what we have analyzed in the MATLAB, which I've just talked about it. Something else we need to appreciate, we also consider the issue of frequency. Remember the ITU issues the frequency to our CAK, and then the CAK now issues to the vendors. This system will be rather economical because it will still use a single frequency for both. If it may be site A, we'll still use a single frequency for both vertical and horizontal polarization. And now we still conserve the EMF spectrum, which you know very well is diminishing because of many frequency use. So it stands the test of time. Now, conclusion. Therefore, to be able to achieve this, which I said, now we need that system implemented, as I've said. It is our next work to design the system because we have collected data and we have seen it's very viable and it's working, and that now will be our next assignment. Thank you.
Thank you very much, Mr. Mwalali, thank you so much for your very nice presentation. I request that you just put down the questions that you may have for him. Because of time, we will have to just go to the next presenter. We make 3 presentations, and then we'll have time to get the responses from the presenters of the questions that you have. So kindly bear with us. Because of time, we'll just go to the next presenter, and then another one, then we'll give them the chance to respond to your questions. Please put down your questions that you may wish to give to them. Thank you. So our next presenter is going to be Mr. Kibiwot. Mr. Kibiwot is around. Yeah, he's going to give a presentation on the topic of optimization of engine performance and emissions fueled by biodiesel blends. Welcome.
Good afternoon. My name's Kibiwot VN. We are co-presenting this work with Nyanga, Njue, and Owino. I'm going to discuss, or rather present to you, optimization of engine performance and emissions. These engines are fueled by what I'm calling the biodiesel blend. So probably, am I able to move? Oh. Oh, yes.
Yeah.
Why is it not moving?
Just click
Enter. Oh, it's already there. So my study, or this study, or our study was on internal combustion engines. As you realize, it is a major driver of our economy these days. And in particular, what we call compression, very commonly known as diesel engines, are very major because predominantly they have higher power output per the unit mass of fuel used. But then unfortunately, these engines emit a lot of green gases, house emissions, greenhouse gases emissions, which pollute the environment. The causes of pollution, of course, we know, global warming, one of them, and also in terms of our health. So in this regard, a lot of researchers have looked at biodiesel as an alternative fuel that can be able to run our engines. But then, unfortunately, then, these biodiesels, when used in our engines, will lead to lower engine performance, lower power, lower efficiencies, and etc. So we consume more fuel. So biodiesels, blended with diesels, have been seen as a fairly cost-effective method or strategy of simultaneously reducing these emissions and at the same time increasing performance. Probably at that point I want to mention that diesel engines, of course, were designed to run optimally on the fossil diesel. But then because of the aspect of emission and the stringent measures which have been put in place, then the biodiesels came in to reduce the emissions. But then as you run biodiesels, engine performance go down. So we're saying biodiesels blended with diesel then will be a very good strategy to have a compromised engine performance and emissions. So in shaping up this, our next interesting point is how then, what level will be the optimal blend level that can give us the best engine performance and at the same time reduce the emissions. That's the main challenge. Many researchers have reported differences in terms of the best level of blending, the best level of blending. And the reason is, of course, biodiesels are normally sourced from various oils. And these oils, which come from vegetable oils, and they come also from the animal fat, have different characteristics, which when, of course, processed, then they lead to a fuel that may not have very similar properties. So the research is aimed at model so that we can be able to reduce the cost of doing experiments, and the models will help optimize the engine performance of a diesel. So this is generally the intention of this research was to try to come up with models. And the models were developed by doing analytical modeling, and then, of course, experiments on engines. And when the analytical models are calibrated using the experiments on the engine test, then we get mathematical models then which can be used to simulate our engine. An overview of what happens really in the engine. The engine takes in air. It also takes in the fuel. Inside there, then it burns in a process which we call combustion. And in combustion, so many things come up. In combustion, of course, we will be burning the hydrocarbons with oxygen in the air. But then we get other emissions because the air has nitrogen, it has also other gases which can be affected by this combustion. Then within the engine, when we burn these fuels, then we get power, the engine power. And this engine power, of course, will be more ideal if we are to burn little fuel, get a lot of power. But then, because of those limitations, we'll realize again that there will be issues there. So why these limitations? As we burn this fuel, the conversion of that fuel energy into what we call the brake power, the power that is available for our users, is limited by what we call the brake thermal efficiency. So overall, then, that explained what happens inside the engine. But then, what is this then that affects our engine? When we talk of engine performance and emissions, sorry, I missed out the emission aspect. We talk of engine performance. What are these engine performance parameters? We have indicated power, brake power, the frictional power, brake mean effective power, and the many other power aspects. We have even the air efficient aspect. And then we have emissions on the other side, the carbon monoxide, carbon dioxide, the nitrogen oxides, and sulfur dioxides. Those are performance indicators of an engine. So you will say, my engine is performing well if it has low in these emissions, and it is high on those performance parameters. What goes into the engine is the fuel, which has properties. And properties can be divided into what we call the physical, the chemical, and sometimes what we call the combustion properties. So I've outlined them there. And then engine. What is this engine? Engine, of course, is a designed component that will do the conversion, that will convert for us the chemical energy in the fuel to the mechanical energy. And in the design, of course, there are what we call the design aspects, which include what we're calling the bore or the cylinder diameter, the length of the stroke, etc., the compression ratio, and the many other aspects that you can see there. Our engines will be operating in an environment, and different environments have different aspects in terms of environmental pressure and temperature. When we operate the engine at Mombasa, for instance, we're dealing with 1 ampere. So the atmospheric pressure there, because it is high, then our engine can induct in more air. When it inducts in more air, then it can burn our fuels with improved efficiency. So those are the parameters that play part in the engine. Now, so for this study, then we had to do a selection of these parameters. And we realized that, of course, the engine performance parameters are interrelated. And so there were 4 selections there: brake thermal efficiency, specific fuel consumption, nitrogen oxide, and carbon monoxide were selected for reasons that, of course, the emissions there, nitrogen oxide is very key, carbon monoxide also very key. In terms of inputs, the blend level, the mix level, the mixture level of the biodiesel and diesel was selected calorific value, meaning the energy content of the fuel, density, and the others played a key part. So upon selection of these variables, then models were developed. And these models, which were developed, we used what is called the Birmingham Pi theorem. Birmingham Pi theorem uses dimensionless numbers. In these dimensionless numbers, then it does comparisons of dimensions to come up with what we refer to analytical. Analytical means the original or the very basic aspect. Of course, the choice of this is we would have looked at developing these models completely using numerical or empirical, running experiments and coming up with this. But then they may not give you very direct correlations that can be scientifically accurate. So Birmingham Pi theorem was used, and then we were able to get these, which we are calling the analytical models. Upon getting the analytical models, we now need to calibrate these models to be able to get the constants that you have seen, the constants that you have seen above. The constants that you have seen above are to be determined using experiments. And of course, we did experiments, as you have seen. We had the fuel properties, and that is how we were able to determine the fuel properties. We ran these fuels on an engine, that is an engine setup. And of course, this is the real engine that we were able to run this. This engine is in Jomo Kenyatta. This engine is in Jomo Kenyatta. These were the experimental design and test modes. We ran this engine using 5 different biodiesels, and blending was done at 5 levels, from 10% biodiesel to 90% diesel, and mixed up the ratios of 30% biodiesel to 70% diesel. Beyond the 30% biodiesel, then the engine efficiencies came down, and so we realized that it may not be of great value. However, controls were done for this experiment at level of pure diesel and at levels of the pure biodiesels. We were also able to set up the engine speed and the engine loads. And the engine speeds and loads were mixed through an expression which was offered by the engine there to what we were calling equivalent power. And so our graphs were plotted mainly using what is called the equivalent power. So using that data generated from those engine test modes and the analytical expressions which were developed by the Birmingham Pi theorem, we were able, feeding them into the MATLAB, of course, coding the MATLAB so that it could be able to give us results. The huge data was compressed, and we were able to get the 4 models, the BTE, the specific fuel consumption, the carbon dioxide, and the nitrogen oxide in form of the blend level, in form of what we are calling PP, and PP is the equivalent brake power, which defines the engine load and the engine speed. And in terms of the fuel properties, which you can see down there, the fuel properties being the density, kinematic viscosity, and the calorific value. So these were the developed equations which will now define the engine. So any other time we want to find out what PT is, then you just feed them simply. Now these models were verified using other biodiesels. We brought in linseed and soya bean. We went through the similar process and we were able to verify. And of course also throughout the verification and the predictions, we realized that these particular models could be able to predict the brake thermal efficiency at 1.65% with a variation of 1.65%, which means fairly close. The one which had huge variation was specific fuel consumption at 16.985%. You can see the others are fairly low. Now, having developed the models, we now want to optimize because we want to get the optimal blend level. The optimization was done by using what is known as the non-dominated sorting genetic method. I want, my time is up, but please allow me, Chair, to just go through this very brief. So the non-dominated genetic algorithm was an algorithm which was developed from genetics. That when you get the first inbreeding from the parents, then you have a better offspring, and so forth and so forth. And so from the non-genetic algorithm method, you could be able to get what is known as the best trade-off, optimal value. That gives you the best emission levels. Remember, we had 2 emission levels, and the best performance level. So NSGA2 was used. Of course, this was an improved version. It is among the latest versions. There was NSGA, NSGA1, and this, we came to this. So in all, we went through the engine optimization through that procedure, and we were able now to get the optimal values for the waste vegetable oil at 22.5% biodiesel to 77.5% diesel. For canola, blended at 19% biodiesel, and so forth to the other biodiesels. So in brief, that is really what we got. So outcomes, we want to imagine that we've generated knowledge for biodiesel formulations, because now from these models you can be able to formulate any biodiesel that you get, be it from the animal fat or the vegetable oils. So using these formulas, they give you a perfect simulation, except for the specific fuel consumption. And indeed, then these models can be able to assist you predict the expected engine performance and emissions for the single cylinder, what we were calling the single cylinder variable compression ratio engine. And then an optimal blend, of course, was able to give an effective and sustainable fuel solution. Thank you, but I want to say we want to acknowledge African Development Bank. It funded this particular study. We used quite a bit of amount of money. We ran the engine for in excess of 6 months, which was quite costly. And Jomo Kenyatta University and Egerton University for giving us the funding through that. Thank you so much.
Thank you. Let's give him a round of clap. Thank you so much, Mr. Kibuot. It's a very interesting presentation focused on saving us from expensive fossil fuel. Please just put down your questions and they'll be responded to together after the third presenter's presentation. The third presentation, before we give them a chance to maybe respond to your questions, is going to be an online presentation by Eric Odhiambo, together with Ongondo and Otachi. Eric, are you online? Can you hear us, please, Eric? Yeah, but maybe the loudspeakers, because I can hear him talking.
Can you hear me now?
Yes, now you are loud enough. Okay, welcome, Eric. Eric is going to give us a talk on the efficiency of a stand-alone recirculating aquaculture system in increasing fish production in a lower middle income country, Kenya. You only have about 10 minutes, and if you can make it slightly lower than 10 minutes, it will really be appreciative due to the time constraint we have. So welcome, Eric.
Thank you, Dr. Good afternoon, ladies and gentlemen. It's a privilege to present to you the work that I did together with my co-authors, Dr. Ongondo and Dr. Otachi.
Can you make it the PPT show, please?
Actually, from my end, it's on presenter mode. Has it adjusted?
Not this side.
Yeah, it's full screen on my end. Let me stop sharing and reshare.
Can you try again? Can you try again, Eric?
Yeah. Has it come up?
Click there.
So I've clicked on this, the slideshow, and on my computer it's slideshow.
Are you the one sharing, or it is us who are sharing?
I think they're sharing their screen, and I'm also sharing. I think you might be looking at the wrong screen. I'm not sure, because mine it's on presentation mode.
Could you please redo it? I think there's a problem somewhere.
Just a test. Do you see my slides moving? I'm scrolling. You can see it moving?
This is John Eric's screen, but it's not moving.
Exactly. So my screen is moving. So we had that challenge with the previous presenters, where we couldn't see their screen moving, but on your big screen we could see it moving. So I think it's a setting there. Dr. how do you advise that we proceed?
Can it be shared from the Egerton?
So those joining online are seeing my screen moving.
Now we can see the screen is moving.
Okay, now I'm going to put it on presentation mode. Let me know when it comes up.
I think just go ahead. Just go ahead. We'll follow.
Okay. Thank you. So it was an assessment of the efficiency of a standalone recirculating aquaculture system. This study was done in Limuru, in Kenya. And I'm going to give you a background of the system, the methods we used, and the results. So basically, aquaculture has been growing over the last 4 decades with over 500% increase. But the biggest issue right now is that the growth is not even. So we have regions like Africa where it's a bit slow. And we've identified some of the factors that are causing this, some of which is input availability, like feed. Big one is technological constraints and the prevailing climates. So I just highlighted technological constraints because it's the theme of the conference, and it's also the subject that our research was based on. So currently, aquaculture is being relied on as a main source of fish since the capture fisheries has been dwindling. Unfortunately for Africa, our aquaculture only contributes 2.7% of the total globally. So that means despite the fast growth rate, we still account for very little in the big picture. Now, if we narrow down to Kenya, our efforts have focused on extensive and semi-intensive systems, which is characterized by the small-scale pond farmers. And through different initiatives like Eat More Fish and the Economic Stimulus Program, we saw our production peak at around 24,000 metric tons in 2014. I have to say that this number has changed significantly over the years, but then there's no clear data from both the government and private sector to indicate what the current production is. Now, with the increasing population and income levels in the country, and of course not forgetting dietary preferences, the demand for fish is most likely to keep increasing. But let's not forget that our resources such as land and water remain limited. So the big question remains, how do we feed our people, especially considering that fish is a very cheap protein source and very nutritious. So our problem was based on the fact that there's a gap in the fish supply, and the extensive and semi-intensive systems are not going to fill this gap. And so we have to look into technological innovations that would help us sort this out. So the overall objective I just mentioned, which was the assessment of the specific system, the fish hub model, and the specific objectives were around productivity differences between a conventional pond and the fish hub, and different water quality parameters. So I'll introduce the elephant in the room, the fish hub model. So from this, it looks like a very complicated system, but it's a simple fish tank that follows the basic recirculating aquaculture system principles. Now, if you look closely, now you'll see the difference between the pond on, it's on my left, I hope it's on your left as well, on the left and the
fish moving, hub. Eric, the slide is not moving. We are not seeing the slides.
You can see the picture? Green? Dr. Steve, which slide are you seeing?
Just the first slide is what you're seeing still.
Oh, that's interesting, because I'm in slide 5. So I handed in my presentation. Is it possible for it to be presented from the room? I can speak through it in the remaining minutes.
We are now seeing it. We are now seeing your slide 5. Is it 5? Yes.
Yeah, it's slide 5.
So you can move them and we will be able to see them.
So I'm in slide 6. You saw the change?
Yes, we can see.
Okay, thank you. So On the left, we have a conventional pond, and on the right, we have the fish hub system. And just to remove the complexity, this system, if you look at the slide I'm on currently, was assembled by locals. You can see we built it using locals in Limuru. And the end product is this a standalone system. That's why we call it standalone. Unlike most indoor systems where we have so many tanks connected to one another, we had this that has the biofilter centrally located and a small mechanical filtration box on the outside. That's the reason why it's called the standalone RAS system. So the idea is to have a knockdown package that even smallholder farmers, if they wanted to invest, would have a small scale RAS system in their farms. Now, the basics on how it works, the arrows show the water flow. So we have blue showing clean water going to the tank, that's A. And then in the tank, the water, the red arrows on the bottom, the dirty water with ammonia from the fish gets into the biofilter, which is this section D. It's cleaned by the bacteria, and then it goes out by the airlift pumps, that is the blue arrows in E, and then recirculates. The dirty water that goes here also comes out through the sludge collector, flows to the sedimentation channel where all the fish physical waste is trapped and then goes back to the tank cleaner. So in short, this small space, water is reused 90 to 95%, and the stocking density can be significantly increased. So like I said, the study was done in Limuru. The average temperatures in Limuru are 12 to 17 degrees. That's during the highest and the lowest months in March and July, respectively. And I put the elevation there because it affects water quality parameters in fish production. So we had a general study design. We had to stock the fish, acclimatize them, and during the production period, which was 60 days, did water quality assessment and sampled the fish. Now, we used all male sex-reversed tilapia and stocked them at 25 grams. Did proper acclimatization so that we didn't have fish dying during the first day, and started feeding at 5% of their body weight. We did water quality assessment. Oxygen was done twice daily, temperature the same, pH the same, ammonia and its subsequent forms were done twice every week. And we used test kits that would ideally be used on a fish farm to make it reflect more on the reality, because these are the test kits that farmers would use. And the sampling was done during stocking when the fish were 25 grams, T1 after 30 days, and T2 after 60 days. So what did we find out? It was very interesting that after 30 days, the fish in the pond had grown to 49 grams. The fish in the fish hub had grown to 84. And after 60 days, when we ended the study, the fish in the pond was 75 grams, while in the fish hub we had 159 grams. So more than twice that of the pond, as you can see from the graph. Now, specific results, we looked at the following parameters. We had a specific growth rate of 2.2 grams per day in the fish hub and less than 1 gram per day in the pond. Now, productivity was very interesting because this touches on the area and the yield. So we had 13.3 kilograms per cubic meter in the fish hub and less than 1 kilogram per cubic meter in the pond. Now you can see the significant difference in the amount of feed that the fish in the different systems were able to consume. And the FCR, as this was very early stages of the growth in the fish, it was just the first 60 days, the FCR in the fish hub was 1, the pond was 2.1. 120 fish died in the pond, 98 died in the fish hub. And we looked at morning oxygen, pH, and ammonia, and these were the averages over the production period. Now, we picked a few of these parameters to see the significance. How much did they affect the rate at which the fish grew and the productivity that we had at the end? So using a Mann-Whitney U-test, we realized that there was a significant difference in productivity between the two systems. And for morning oxygen, morning temperature, and pH, which were the top 3 water quality parameters that affected the difference in the growth rates. So the significance here is not just the significance between the difference between morning oxygen in a pond and a fish hub. This was the significance of their effects to the growth rate of the fish. So we realized that morning oxygen, morning temperature, and pH were the biggest factors, where by controlling these 3 factors, we were able to have fish growing twice as fast in a fish hub as compared to a pond. So productivity was significantly higher, and there was significantly more control of water quality parameters in a fish hub as compared to the pond. So to conclude, based on this performance, we can tell that this technology was able to control culture parameters, ensuring that we had optimal conditions for fish to grow in. Hence, the performance was significantly better. Now, key inputs such as land, water, and feed, their efficiency increased because that's what you're looking at. The FCR of 1 is very good because it means that for every kilo of feed, we were getting a kilo of fish. You can never get a better efficiency as compared to that. Whereas in the pond, we had to feed 2.1 kilos of feed to get 1 kilo of fish. And you can look at water usage for every kilogram of fish we produced in the fish hub. We only used 50 liters as compared to 5,000 liters in the pond. So that was efficiency of key inputs, land, water, and feed. And we realized that we can actually leverage this technology to grow fish in areas that are considered to be not suitable. So we did this intentionally in Limuru because it's very cold and tilapia is a warm water fish. And we are saying, as we have more pressure around Lake Victoria, how can we alleviate that by growing fish even in areas where we don't have suitable conditions? And we think we can leverage this. And my recommendations are, 1, we need to start seriously considering the use of RAS for grow-out production of fish, as we've right now taken it up really well in growing fingerlings, which is going really well. So for grow-out production, studies like this will show that it should be used. We should also do more studies and do cost-benefit analysis, because as you can imagine, the capital of investing in this system is significantly higher than just constructing a pond. But then we should not make assumptions based on that. We should do serious cost-benefit analysis and see when is it worth it to invest in such systems. Now, I think we also need to do a study comparing this system and a cage, because cage farming has become really popular as compared to other systems, and see in achieving intensification, which is something we're doing with cages. Can cages compare? How does cages compare with RAS? We need to do that. And my study was 60 days. So maybe if we did a full cycle study, we would paint a better picture. But I believe that what we have here is clear indication, and looking at the dashboard, we can see that the system actually works. So thank you for your time, and apologies for the interruptions in the presentation due to the PPT showing and not showing whenever it felt like. Back to you, Dr. Ari.
Thank you, Eric. Very nice presentation. We are sorry that we could not see the slides, but at least from what you've seen, this is something that is really, really promising. growing tilapia in the cold Limuru and achieving those kind of FCRs is something that one has to be proud of. I think we had said that after 3 presenters, then we come to the question and answer session, but I would wish to request that the next presenter is also online, and so that we don't miss him, I would request that we go straight to that presenter, who is Tembo, and then we come to the question and answer session. Tembo, are you still there?
Yes, I'm there, Dr.
Yeah, I would wish to request that we have your presentation, if you can share it on the screen.
So can you see my screen?
Yes, we can see your screen, and try to put it through the PowerShow, the slideshow rather. Yes, it has come. Thank you. You have less than 10 minutes to give the presentation. Just focus on the key findings.
Thank you. Good afternoon. My name is Jeffrey Tembo, and I'll be presenting to us a part of my MSc work that we've co-authored together with Professor Kitaka, Dr. Key here, Dr. Brian, Dr. Hazel, Dr. Mbaro, and Ms. Kariuki. To begin with, biotic interactions are among the most driving ecological drivers that influence our distribution of fish populations. However, you see overlap in terms of biotic interactions are also among of those ecological interactions that basically influence the structure and ecosystem functions of our system, and these basically they pose profound effects to key migratory species that including eels that they normally move within their ecosystem throughout from the oceans to the rivers, then come back to the oceans again. And so these migratory fish are already affected by other interactions, especially when they interact with the piscifaunas and all the other associated species. And so we are saying within the Wio region, the anguillids, such as the 3 species that are known to occur within the Kenyan rivers, but however, recent review indicate that some of these species are nearly threatened, maybe because of data limitation. And so we are not sure if these biotic interactions, such as habitat interaction, could be contributing to some of these declines of this our very lucrative and slippery species. So the objective of this study was informed by one major objective, that was to examine and be able to understand the patterns of the habitat exploitations. And so we are able to drive a number of objectives out of the major objective, and the main one of the objectives was to be able to appreciate these fish species that occur with freshwater eels, basically the occurrence, and therefore after that able to evaluate the habitat preferences among the sympatric fish and the eels, and also to be able to investigate and compare the patterns of habitat preference and condition among the fish species and our eels. So basically, we had 3 hypotheses that were derived from the 3 major objectives. And so, why are we doing these studies? Because the habitat utilization for resource portioning is very important. And like I said before, this contribute or rather influence the distribution of our fish species within our ecosystems. And so understanding, you see, the patterns of habitat overlap is very important to be able to appreciate how these species share resources, be able to understand the habitat overlap to inform the best management measures. And so the information that will be generated, or rather generated from this study, will also inform to be able to understand, the vulnerability status of these our eels, and also contribute information to the Convention of biodiversity that is very key in terms of biodiversity strategy action convention of migratory species, and also this will inform to part of a policy, education, and also knowledge transfer to other generations that will be coming after us in terms of research and development. So the study was basically conducted in two flowing rivers in Kenya. And so here we are talking of the Athi Galana Sabaki River. And so in Athi Galana Sabaki River, we were able to do two sampling areas, one at the upstream and one at the downstream. And then later we also sampled Ramisi River that is found south, part of the coastal region. And also we had two sampling sites in that river also. And so within this river, specific areas were selected. And so we had three dominant biotopes that were selected within the different reaches of the rivers, both upstream and downstream, including pools, reef folds, and vegetation edges. Specific gears were used. This include the double thickness that you can see on top. So you can see on top here, this is a glass eel thickness, and on the bottom here, you can see this is a double thickness. So these kind of nets were used to basically capture the eels and also the other sympatric fish from different, of course, biotopes and habitats. And so the landed fish were counted and measured, and also, some other morphometrics were conducted based on fish base and also other guidebook material like the ones for Wanja 2013. In terms of our data analysis, we are able to present the discrete statistics in form of standard deviation and error bars, and also the data was first subjected to normality tests, including Shapiro-Wilks test. And so most of these analyses were done based on the kind of information they wanted to derive. We used the specific softwares, including PAST, Minitab, and the SPSS. And of course, all of them were done at a significant level of 0.05. And all the graphs that are presented in this presentation were also drawn from Sigma plots. So again, in terms of the data analysis, we said the first objective, we're able to achieve it through using assemblage indices. We presented the information in terms of abundance and relative abundances. NMDS analysis will be able to use to analyze the type of habitat types, and in terms of utilization of the biotope by the different fish types. This includes the eels and also the freshwater eels. Pamanova was used to just to establish the comparison between the assemblage and also the habitat types. CCA basically was used to be able to appreciate the relationship between our sympatric fish and also the eels and also the water quality parameters in terms of how the water quality or other environmental gradients are influencing distribution of these organisms within our systems. So the first objective was just to help us appreciate the kind of organisms that we have between the sympatric and also our eels. So we found out that in Athi River, it was much dominated by sympatric fish compared to eels. And while if you compare in Ramisi River, the river was largely dominated by eels compared to the sympatric fish, where the other associated fish species. So over 77% was composed of sympatric fish in Athi River, while 77% was composed of eels in Ramisi River. So this already gives us an indication of the importance of these two rivers. So most of the estuarine fish and Orochromis loriticus were more prevalent, especially in all those rivers, while the eel species, the Anguilla bengalensis, was the most dominant among the population of the eels. And so if you compare among the rivers, you find that Anguilla bengalensis was the highest among the rivers, especially in Athi River, followed by Oligolepis acutipenis and sorry for the interruption. And so if you look at Athi River, most of the species were dominated by one species of eel, which is Anguilla bengalensis, and also some other goby species, but of course also there was one of the introduced species of tilapia, the Olochromis nauticus, which was also dominant. If you look at the Ramis River, you find that, again, Anguilla bengalensis was the most dominant species, of course, followed by Olochromis nauticus, that is one of the most introduced species, and also some other goby species, which we envision them as of the higher trophic level that can compete with our eels. If you look at this table, you realize
Tembo,
that
due to time constraint, may I request that just give us the summary of the results and then you make your conclusion. Sorry for that.
Okay.
Due to time
Okay,
constraint.
thank you. So we'll go quickly to. So if you look here, most of the eel species are associated with pools, especially at Ramis River and also at Sabaki, at Kiaoni. If you look at most of the influencing variables among the rivers were temperature, salinity, and velocity, which are very key in terms of distribution of our organisms. So the most, so to conclude, we are saying that most of our sympatric fish, especially the Olochromis nauticus and some other goby species, were the most influencing species to our eel. And this is because some of these goby species are of higher trophic level that they can easily compete with our eels in terms of habitat exploitation and also, diet overlaps. And so we are saying the utilization of a pattern of habitat showed differences because we find that most of these organisms equally share similar habitats, and so they tend to compete in terms of resource utilization. So our recommendation would be we need to prioritize preservation and enhancement of habitats that are able to support concurrence of both sympatric fish and also the eel, especially that can favor most of these estuary species. And also we need to support development of integrated habitat management that can be implemented to consider in terms of how these species are able to utilize similar habitat utilization. And also we need to develop ecosystem-based management practices that can also inform in terms of management of this fishery, as we all know that eels are very lucrative in terms of fishery contribution, and also these fish are migratory species. So I would like to acknowledge my supervisor. This is Professor Kitaka, Dr. Charles Kia, like I said before in my introduction, Professor Gordon, and the institution who are partners in this project include the WIOMSA, who was funding this project, and also the Rotary Club of Vienna that was also generously supporting this project, and also the community members and other partner institutions that were able to take part in this project. And so with that, then I would like to say thank you very much for your time and for your attention.
Thank you very much, Mr. Tembo. Let's give him a round of clap. And with that, I would like to invite the four presenters, Mr. Mwalali, Mr. Kibiwot, Eric, I hope you're still online, and Tembo, for questions and answer session, which will be short. My suggestion is, due to the time constraint, they may answer one question each, and the other questions, of course, they'll be given to respond to, which will then be shared. So I invite Mr. Mwalali, Mr. Kibiwot, and the other two are still online. So the questions, please. Questions? Yeah. Questions from the audience, or you have them in cards already? Yes. Yes.
Okay, it says this: with the increase in research on the production of biofuel, like bioethanol, as potential replacement of gasoline, whose combustion results to the release of greenhouse gases? Will biofuels production minimize global warming? That is from online.
Biofuel production, will it minimize global warming?
Can I respond? Yeah, it is part of the mitigation measures. We're saying in addition to the other measures, including, for instance, the converters, then biofuels, yes, will add up to minimizing global warming. Why? Because biofuels are fuels which we grow, and these fuels, as they grow, they consume the carbon dioxide that is emitted into the environment. So within the cycle, then yes, it will reduce. But in addition to the other mitigation measures, thank you.
Just connected with that question, the combustion of these mixture of the biofuels and the fossil fuel, the ratios that you are working with, what proportion of carbon dioxide was being generated from the combustion? Is it significantly lower than the normal combustion of the fossil fuel?
Yes, indeed. I never presented the real data because there was a huge data, but it does reduce the overall emissions. And then in addition, we're saying also the plants will consume part of that. Thank you.
Thank you. Any other question to the presenters? Questions to the presenters? Yes?
Thank you once again. My name is Imali Dixon. How cost effective is the biofuel?
How cost effective is the biofuel? That again goes to Mr. Kibiwot.
Yes, thank you. Thank you for that good question. One major challenge about biofuels has been the cost aspect. But with blending in place, then, and with also the increase in the terms of the varieties of the plants, then the costs are coming down. But generally in the earlier times, the costs have reasonably been high. Thank you.
Okay, thank you. Another question?
Good, we're good.
Any other question from the floor? If not, yes? Yeah, there, behind you.
I had two questions, and one relates to the science of density and kinematic viscosity in biofuels. Do the two vary with temperature, as in water, or are they constant? Because I expect that if they are variable, then the performance of the engine would be affected by variability in temperature.
Can I answer?
Question, or you want one first? Okay, fine.
Yeah, viscosity in particular varies reasonably with temperature. Density, yes, the variation is there, but it's not as much. In terms of the variability, these engines, of course, will be ran from one point to another, and we were only comparing the engine emissions and performance for that very specific engine running on the fossil fuel. So indeed, I indicated within my assumptions that at the end of the day, yes, the variability is there. But within a given environment, variabilities we noted at Jomo Kenyatta were less than 5%. So, which was low enough not to affect the emissions and the performance of the engines. Thank you. But generally, we're saying there is, yes, variability.
Okay. Thank you. If there is no any other question, then I think we may stop at that point, and let's give another round of clap to the presenters. And the last presentation, hopefully he's in, Mr. Liaka. Mr. Liaka, Gwena, and Milewa. Liaka, Gwena, Milewa. They're not there. Okay, then that brings us to the end of this session of presentations. I'm sorry it has taken more time than was planned for it, but because the presentations are very interesting. So with that, I want to say thank you so much for listening to the presentations. Thank you so much, the presenters, for the good work, and let us clap to all of us who are here. Thank you, and that I now invite I was trying to invite him to make the announcement, but he's insisting he doesn't want to talk. I'm told that we break for lunch shortly, and then at 3:30, we converge here for a keynote address by Dr. Susan Weiss, an associate professor in the Department of Media and Information, Michigan State University. That will be virtual, eh? Okay, fine. So 3:30, we are told that you have at least an hour for lunch break. Thank you, and you have a good afternoon.